Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Okay, good morning students. Today we are going to see the second unit. We are going to start the second unit, that is biosignal characteristics and electrode configuration. These all comes under the second unit, that is what? Biosignal characteristics and electrode configuration. Okay, have you understand? What is our second unit? Okay, biosignal characteristics and electrode configuration. Okay, in this we are going to study about the characteristics of various signals and also what are the configuration that are used for measuring various signals. ECG measurements, we are using some configuration. EEG signal measurement, we are using some configuration. That all comes under the second unit. Okay, biosignal characteristics and electrode configuration. What is a biosignal? Can anyone say what is a biosignal? Okay, it is any signal in the living being that can be continuously measured and monitored. Okay, that is the signal which we can able to be continuously monitored and measured is called the biosignal. It is often used to refer the bioelectrical signal. Okay, they will study in the next video, I think. Okay, today we just start our topic, electrocardiogram. Okay, I think many of you know about this electrocardiogram, is it? Okay, let's start our portion. ECG. Okay, there are various terms: electrocardiography, electrocardiograph, electrocardiogram. What are the difference? So, what is electrocardiography? So, we are just studying that method, that is, this is the technique by which the electrical activity of the heart are studied. That is called electrocardiography. Okay, that is the technique by which the electrical activity of the heart are studied. Then, what is electrocardiograph? That is, this is the instrument by which the electrical activity of the heart are recorded. What is the electrocardiograph? It is the instrument by which the electrical activity of the hearts are recorded. Next one, electrocardiogram. What is electrocardiogram? It is just the ECG wave pattern. That is the recorded graphical representation of the electrical activity of the heart. That is the electrocardiogram. That is the ECG wave pattern. This ECG is sometimes known as EKG. Okay, EKG. That is also electrocardiogram. The spelling is different. K-A-R-D-I-O, cardio. Okay. So if they ask about EKG also, it is called ECG. Okay. So using this ECG wave, we cannot able to identify the valvular defects. Okay. So if we want to identify the valvular defects, means we have to use another techniques that is called phonocardiography. Okay. So using the phonocardiography only, we can able to identify the valvular defects. Okay, so how this ECG gives if there is any problem in heart? So that is this ECG waveform have a particular shape. If the variation in the shape, time interval and amplitude of the ECG signal From that variation, we will identify whether there will be some problem with the heart or heart. I told you there is a rhythmic waveform. This figure shows the waveform of the ECG. Okay, so the ECG, what is ECG? Which measure the electrical activity of the heart. You know, right? ECG-ElectroCardioGraph is the electrocardiogram is the record of the electrical activity of the heart. Okay, what about the 4 chambers of the heart? What about the 4 chambers of the heart? Right atrium, left atrium, right ventricle, left ventricle. So these are the 4 chambers of the heart. What about the top 2 chambers? That are the atrium, and the lower 2 chambers are the ventricle. The right atrium receives the blood from the vein and it pumps to the right ventricle, and the right ventricle pumps blood into the lungs where it is purified and oxygenated. That is, the right atrium receives the blood from the veins and then it pumps to the right ventricle, and from this right ventricle it pumps the blood into the lungs. In the lungs it is get purified and it is mixed with the oxygen. Okay, then this oxygen mixed blood is entered into the left atrium, from which it is pumped into the left ventricle. Then the left ventricle pumps the blood into the arteries through aortic valve for the circulation throughout the body. Okay, have you understand this? That is, first the blood is entered into the right atrium, then it pumps into the right ventricle, then it goes to the lungs for the purification and oxidation purpose, then it again comes back to the left atrium, and then to the left ventricle, and then it passes to the various parts of the body for the whole purpose. Okay. So it need proper pressure, and sufficient pressure is delivered by the ventricular muscles contraction, which is achieved through the cardiac action potential. So there will be various operations takes place for this method, from right atrium, then right ventricle, then to the lungs, then to the left atrium, then to the left ventricle. So okay, so the typical bandwidth of this ECG waveform is 0.5 to 125 Hz. This is the typical bandwidth of this ECG waveform. And the typical amplitude, what about the amplitude? It is 1 to 10 millivolt. And the typical waveform is the rhythmic waveform. What is that? It is the arithmetic waveform. This figure shows the ECG waveform P, Q, R, S, T and U. These are the waves. P wave, Q, R, S wave, T and U wave. So this P wave, what is P wave? P wave is the arterial depolarization. That is the depolarization of the arterial, arterial portion. So next one, PQ segment. PQ segment is the atrioventricular nodal delay. That is, the node, this atrioventricular node is located in the lower part of the wall between the two arterioles. Okay, so the AV node delays the spread of excitation. Okay, it acts as the delay line. This AV node acts as the delay line. So PQ segment is the atrioventricular nodal delay. From the name itself, it is the delay line. Okay. Next, QRX complex. QRX complex is the ventricular depolarization. First one, arterial P wave is the arterial depolarization. Then QRS is the ventricular depolarization or arterial repolarization. First the arterial wave is depolarized, then when this QRX part is depolarized, the arterial part goes to repolarization state. Okay, so then next the ST segment, which shows the ventricular ejection period, then T wave shows the ventricular repolarization state, and TP stage segment, that is the ventricular filling period. Again, I'm back to the TP, that is the ventricular filling period. So next, what is depolarization and repolarization? That will be learned in the waveform. There are two names. P wave means arterial depolarization. What is the depolarization? So when the electrical activity occurs, heart muscles fibers are contracted and produce a movement. This condition is referred as depolarization. That is just the contraction. Okay, the contraction of the muscles called the depolarization. That is when the blood is pumped around the body, it results in the contraction. When chambers are contracted, it is called as systolic. That is when the blood is pumped to the various parts of the body, it results in the contraction of the valve. This results in systolic. Okay, that is studied in the next unit. Next, repolarization. What is repolarization? That is the relaxation of the heart muscles are called repolarization, and it is called diastolic. So if the chambers are contracted, it is called systolic, and relaxed means it is diastolic. In the contraction stage, it is called repolarization, and in relaxed stage, it is called repolarization. Next, you all know, if you want, we are measuring this, right? ECG measuring. So we need a block diagram, that is the ECG recording setup. In this ECG recording setup, it consists of various circuit. Okay, so this figure, this is the lead system. Okay, there are various lead systems that you studied after this. Okay, so this is a human body. Okay, human body, right arm, right leg, left leg. Okay, this ECG recording setup consists of various circuit, that is defibrillator protection circuit, lead selection logic, calibration circuit, pre-amplifier, and power amplifier. These two comes under the bioamplifiers. Then feedback network and output display unit. Okay, so the patient cable is connected the different lead from the limb and chest through the defibrillation circuit. These means that is there is a connection in right arm, left leg, and right leg. This shows the connection of various electrodes in a human body. So this is connected to the defibrillator protection circuit. Okay. So this defibrillation protection circuit consists of a power amplifier and over voltage protection circuit. This consists of what? There are two. That is the power amplifier as well as the over voltage protection circuit. So if there is some over voltage comes in, it will be protected by this defibrillator protection circuit. The LEDs are connected with the buffer amplifier with the buffer amplifier for each patient LED. So this is connected to the buffer amplifier. The input impedance is increased and the electrode impedance variation will decrease. Okay, that's this defibrillator and protection circuit mainly consists of a buffer amplifier. It acts as an voltage protection circuit. Then from the defibrillated circuit, it goes to the lead selection logic. There are three types of lead selection, that is lymph lead, augmented lead, unipolar, chest lead. So that which type of lead? That is the method. Okay, method of recording this ECG. So which method is we need, that will be selected in this lead selection logic. Okay. So this calibration circuit. So in this portion we will select the types of lead. Okay. So due to that selection, if there is any artifacts in that, it will be cleared by the calibration circuit. Okay. Next it goes to the bioamplifier. In this bioamplifier, it consists of a pre-amplifier as well as the power amplifier. Okay. This pre-amplifier is a differential amplifier with high gain and a high common mode rejection ratio, and it is followed by the power amplifier. Okay. This power amplifier, it is used to drive the recorder, just to record the measurement. It is used. Okay, power amplifier, it is used to drive the recorder. So pen motors in this recorder requires sufficient electric power. So for the recording we are using pen motors. Okay, so if we want to activate that, we need sufficient electric power. So therefore this power amplifier requires high gain. Next, output unit. The output unit is the display. Okay, it is displayed normally means we know, right? It is displayed in a cathode ray oscilloscope or a paper chart recorder. Okay. The power amplifier or pen amplifier supplies the required power to drive the pen motor that records the ECG trace. Okay, on a wax coated heat sensitive paper. Using this, there will be special type of paper, that is a wax coated heat sensitive paper, and in that paper we will mark the ECG signal using pen motor. The speed of the paper is 25 millimeter per second. Okay, the fastest speed is 50 millimeter per second. If you want, you can note down these points. Okay, I will just I think you understand this. So defibrillator protection circuit. The on end of the electrode LEDs are connected along right hand, left hand, chest and left leg of the patient. The other end of the electrode passes through the defibrillator. We know the electrodes are using, right? So one end of the electrode is placing in the patient, and the other end of the electrode passes through this defibrillated protection circuit. It consists of a power amplifier and an overload protection circuit. Next, let selection logic. This block helps to select the type of electrode LED system. We can choose either bipolar or augmented electrode system. Then calibration circuit. As I told you, it's just the error correction circuit here, that is eliminating the error in this. Calibration is the processes that have to eliminate error in the system. Here, any changes in the LED selection, suppose if you take bipolar, means there will be some error. If we switch on to the augmented electrode also, there will be some error. That all will called as the artifacts. There will be some noise, that is called artifact, and it will be cleared using this calibration circuit. So it helps the technician to correct the error in the ECG output. That comes under this calibration circuit. Then we are using two amplifier, pre-amplifier as well as the power amplifier. This pre-amplifier and power amplifier comes under the bioamplifiers. Okay, the pre-amplifier is an instrumentation amplifier and a differential amplifier with high gain and high common mode reduction ratio. Okay, just as it's a differential instrumentation amplifier, it is an instrumentation amplifier or either differential amplifier that we study in the next unit. Okay, amplifiers. Then power amplifier, the output unit is driven with the power amplifier. After the signal is amplified using pre-amplifier, it goes to the power amplifier. The output unit is attached with a pen motor. The high electrical power is required to initiate the recording with pen recorder. Hence, a high power gain amplifier is used as power amplifier. Next, there will be a feedback network. It is used to provide the damping to the pen motor. Then output display unit. It is either a CRO or a pen chart recorder which acts as the output device. Hope you all understand this ECG recording system. From the LED selection, it is connected to the defibrillated protection circuit, then to the LED selection logic where it selects the type of LED configuration needed. Then the calibration circuit. What is the calibration circuit? It removes the artifact presence in the type of LED configuration. Then preamplifier and the power amplifier. Then to the output display unit and RC feedback network. And what is auxiliary amplifier? Just it is a common mode reduction amplifier. Okay, that is the reference electrode. The reference electrode is connected to the auxiliary amplifier and then to the logic selection logic, LED selection logic. These all comes under the ECG recording setup. Hope you all understand this topic. Then we are going to the standard 12 LED system. Okay, what are the three types of electrodes we studied? Microelectrode, surface electrode and needle electrode. So the electrical signals from the hearts are measured with the surface electrode. So from the surface only we can able to take this ECG signal. The resulting voltage in the heart conducts to the body surface. So the voltage from the heart is conducted to the body surface using this surface electrode, then goes for the measurement. So the standardized electrode positions are used to record the ECG. There will be some positions that we will study them in the next slide. The three types of electrode system. In this standard 12 LED system, we are studying about three types. That is normally from the name there will be 12 LED system that comes under this. That is in the bipolar limb LED or standard LED system. There will be three electrode: LED 1 system, LED 2 system, LED 3 system. Next, in the augmented unipolar limb LED system, there is three. That is AV, or what is AVR? Augmented voltage from the right arm. Next, AVL, augmented voltage from the left arm. And AVF, augmented voltage from the foot. That is augmented unipolar LED. And next, the unipolar chest LED. In this chest LED we are studying about 6 LED in the chest. So totally 12 LED system. So the standard 12 LED system is mainly used to measure what? ECG signal. The first one, bipolar limb LED. Okay, this bipolar limb LED is also called as standard LED or Einthoven's LED. Okay, it is also called as standard LED or Einthoven's LED system. So in this we are using 4 positions from our body. Okay, in this LED system the voltage is recorded from the 4 position of the body, that is right arm, left arm, right leg and left leg. Okay, so in this the right leg acts as the reference electrode. Okay, so in this bipolar limb LED, it is of 3 types: LED 1, LED 2 and LED 3 system. Then first one, LED 1 system. Okay, from the figure, right arm, left arm, there is a connection of electrode in right arm, left arm and right leg. Okay, this right leg, the electrode that is connected in the right leg acts as the reference electrode. Okay, if the LED is obtained between a negative electrode, here the negative electrode is placed. So negative electrode is placed on the right arm, positive electrode is placed on the left arm. So it gives an voltage V1. This, that is in LED 1 we get the output voltage V1. So here the voltage drop is from left arm to right arm. So here the voltage drop is from left arm to right arm. This is just a LED 1 system where we are connecting the LED and how we are measuring. Here the voltage is drop is from left arm to the right arm. Similarly, in LED 2 system, in a LED it is a LED obtained between the negative electrode placed on the right arm. Here the negative electrode is placed on the right arm and the positive electrode is placed on the left leg, and this RL right leg acts as the reference electrode, and here we get the voltage V2 and the voltage drop is from left leg to right arm. So in this LED 3 system also, the positive electrode is connected in the left foot and negative electrode is connected in the left arm, and the reference electrode is connected in the right leg, and we get the output voltage V3. The voltage drop is from left leg to left arm. This comes under the bipolar limb LED. These are the 3 LEDs. Next, in this is the Einthoven's triangle, and it is an important 2-mark question. Okay, this Einthoven triangle is an important 2-mark question. You have to study this. Okay, this closed path, that is right arm, left arm, and left leg. This constitute a closed path, and it again it connects back to the RA, that is right arm. That is called Einthoven's triangle. Okay, so the vector sum of the projection on all the 3 sides is equal to 0. So here we are using Kirchhoff's voltage law. Here there is LED 1, LED 2 and LED 3, right? So the R wave amplitude of LED 2 is equal to the sum of, this is the opposite direction current. So when we apply Kirchhoff's voltage law, this voltage in the LED 2 is equal to the voltage in the LED 1 plus voltage in the LED 2. This is the Einthoven's triangle, that is V2 is equal to V1 plus V3. Just this is the normalized values of this LED 1, LED 2 and LED 3 in this Einthoven's triangle. Okay. That is here in this LED 1 is the potential between right arm and left arm. LED 2 is the potential between right arm and left leg. LED 3 is the potential, here it generates the potential between the left arm and right leg. Okay, have you all understand this Einthoven's triangle? Okay, hope you all understand. Then we can go to the next topic, that is augmented unipolar limb LED system. Okay, in this augmented unipolar limb LED system, this is introduced by a scientist named Wilson. Okay, so the ECG is recorded between a single electrode and the central terminal. So there will be a single electrode and the between a single electrode and a central terminal. Thus, 2 equal and large resistors are connected to a pair of limb electrode and the center of this network. Okay, and from the next figure you will understand it. The remaining limb electrode acts as the exploratory single electrode. That is, the remaining electrodes will act as a single electrode. Using this, a small increase in the ECG voltage can be realized. There are 3 types of augmented unipolar limb LED, that is augmented voltage of the right arm, augmented voltage left arm, augmented voltage of the foot. Augmented unipolar limb LED. Okay, under that first one, LED AVR. What is AVR? Augmented voltage right arm. Okay, this is the right arm. So as we learned in the last slide, there will be 2 resistors. So here is the two resistors from left foot and right arm, left leg and left arm. Okay. So the two resistors are connected to the left arm and left leg. So the middle point of the resistor connection is connected with the middle point is connected to the negative terminal, and the right arm is connected with the positive terminal of the amplifier. Okay, and here also left leg is connected to the act as the reference terminal. So from this we get an voltage, that is AVR voltage, which is equal to minus V1 minus V3 by 2. Okay. Have you understand? That is, here there is a two resistance between left leg and left arm. It is connected together, and from the central point we are connected to the negative terminal of the amplifier, and from the right arm we are connecting to the positive terminal of the amplifier, and from the right leg we are using this as a reference electrode, and from that we get the output voltage. Next, an augmented voltage of the left arm, AVL. So the main positive terminal is connected to the left arm, and the resistance is connected to the right arm as well as the left leg. So from the central terminal of the resistor we are connecting it back to the negative terminal, and RL acts as the reference electrode. So here also a voltage is generated which is equal to V1 minus V2 by 2. That is, V1 and V3 are the bipolar lead voltage. Then augmented, in the next one is lead AVF. What is AVF? Voltage of the foot. Okay, augmented voltage of the foot. So here the two resistors are connected to the right arm and the left arm, and from the central terminal we are connected to the negative terminal, and from the left leg we are connected to the positive terminal, and from the and RL, the electrode is placed in the RL, right leg acts as the reference electrode. Okay, so here also there is an voltage generator, that is minus V2 minus V1 by V2. V1 and V3 are the lead voltage, bipolar LED voltage. So next one, unipolar chest LED system. So here in this, the exploratory electrode is obtained from one of the chest electrode. In the chest we are placing 6 electrodes in 6 different points on the chest close to the heart. That is, the chest electrodes are placed at 6 different points on the chest close to the heart. By connecting 3 equal large resistors to RA, RL, LL, right arm, right leg, left leg, a central terminal is obtained. This LED system is known as Wilson LED system. Okay, here the figure shows this. V1, V2, V3, V4, V5 and V6. These are the 4 LED system. Okay, 4 LEDs. So here in this, by connecting a 3 equal large resistance to left arm, right arm and left leg, a reference electrode or a central terminal is obtained. This LED system is known as Wilson LED system, and this the electrocardiograms of a record for the 12 LED section. Okay. So here this V1 is the 4th intercostal space of right sternal margin. That is the position, okay, where we are placing this LEDs. V2 is the 4th intercostal space at the left sternal margin, V3, it is the midpoint between V2 and V4. V4 is the fourth intercostal space at mid clavicular line. V5 same as V4 position but on anterior axillary line. V6 same as V4 position but on mid axillary line. These are the positions of the lead system. So for this, for identifying these LEDs, so that is the ECG potential are measured with color coded LEDs according to this. That is the white is used for right arm, green is used for right leg, brown for chest, black for left arm, and red for left leg. Okay, that is the positions where we are placing this. Then how we are connecting this? So we know that normally for measuring two electrodes are needed. One is the reference electrode and another one is the normal electrode. So if we are taking V1 means the reference negative electrodes, that is the lead is obtained between, that is the voltage is obtained between the reference negative electrode and the positive electrodes placed on the chest in the V1 position. That is where we place it. And V2 is a lead obtained between the reference negative electrode and a positive electrode placed on V2 position. Similarly, in all there will be a reference negative electrodes, and if V6 means where we place, that is the sixth electrode that is placed in this chest. That is the position V6, that is here. Okay. So these all comes under the unipolar chest lead system. Hope you all understand the topics, and if you have any doubt you can comment or WhatsApp me. Okay, thank you. We can see tomorrow. Thank you.